So when we think of transaction prerequisites, it's really just fundamentally any pre-transaction logic for an application. It's something that over time becomes more necessary as you build more complex applications. And we saw this in Web2. If you look back in Web2, you have applications like Uber, Venmo, Netflix, any of these. So all of them have highly custom and crucial pre-transaction logic. There has to be a fundamental technical reason for why you want to do it. I think earlier in the cycle, there were a number of projects who said, oh, let's use this as a narrative, a way to bootstrap our narrative. But it wasn't so much that they really needed Eigenlayer. If you're building anything, your real focus should be, what am I solving? It's all about bootstrapping your network, and it's all about, in my mind, you always solve for the hardest part of your network. And in this case, Eigenlayer essentially let us do that.
Eigenlayer has done incredibly well this year. Why do you think that was the case?
They built something very novel. When people understood the value of what they were building, say, wait, there's actual real fundamental value here. There's a need, there's demand. And this does enable a new paradigm for how applications are built. There's the academic component, there is a technical component, and then there was a degen component at points. I think if they didn't have one of those, it would have made it likely less successful.
Hi, Nikhil. Thank you so much for joining Depesh and I on Innovate and Grow today. We're really excited to have this conversation. And before we dive into it, we also just want to say a massive congratulations to your recent fundraising round of 7 billion. So well done on that. So as a short introduction, Nikhil is the co-founder and CEO of Predicate, and Predicate is a network for simplifying transaction prerequisites. But we'll let him dive into that a little bit more. And he's the former head of strategy and innovation at Silo Foundation.
Great. Thanks, Maddie. Thanks, Depesh. Great to be here. Thanks so much for having me.
Do you want to start off by giving a detailed introduction? We'd love to understand your background a little bit more and how you came to founding Predicate.
Yeah, so kind of my background before going into deeper on what Predicate really is Maddie, as you mentioned, before this, I was head of strategy and innovation at the Silo Foundation. Led a lot of the major Web3 launches on the Silo blockchain. And then separate from that, I've also been really active in the digital asset policy space as a senior fellow at the Atlantic Council. The Atlantic Council is a DC-based think tank where my role is primarily on the intersection of geopolitics and economics. And a lot of that overlaps with digital currencies. And then I started my career over a decade ago in economic consulting in the litigation space on securities and antitrust, and then also spent some time in management consulting. So a lot of that kind of actually feeds into really what we're doing at Predicate. So as you said, we simplify transaction prerequisites. So what in the world does that actually mean? And why does it matter? So when we think of transaction prerequisites, it's really just fundamentally any pre-transaction logic for an application. And it's something that over time becomes more necessary as you build more complex applications. And we saw this in Web2. If you look back in Web2, you have applications like Uber, Venmo, Netflix, any of these. So all of them have highly custom and crucial pre-transaction logic. So we can make that a little bit more tangible here as well. Let's take Uber. When you go and request an Uber, on the back end they have what they really call a policy engine, policy apparatus. And on the back end, what they're doing is saying, hey, you've just requested an Uber. What type of car did you request? Where are you calling it from? What's your Uber rating? Do you have your credit card number in there? All those different, and a number of other facets, right? It's pulling all that. Where do you need to go? It's pulling all of that together. And then based off of that pre-transaction logic, it's then matching you to another driver. And that driver also has a number of pre-transaction requirements and logic to be matched to you as a writer. All of that is done on the back end to ensure that you get to where you need to go. This is just common for applications that you have pre-transaction logic before they execute. So that's in Web 2. But then if you look in Web 3 and you have this greater complexity of, applications and teams that are trying to better connect to the global economy, you can start seeing where there is that complexity. Because an application, a community that has a decentralized community that is involved in an application, any of those things, they have to navigate a number of different rules and requirements for who interacts in their system, how those interactions are done, how that intersects with a global economy as they're scaling. Like a startup might start, one of the things in crypto is you don't start locally, you start globally. If you start globally and you're trying to then tap into a global market, you have to be able to navigate, rules and regulations for governments, local, business requirements, all of those things. And all of those things are highly complex. And so really what we're saying is there is a way to simplify that. And that's where we come in.
What's the sort of the genesis of Predicate?
The genesis for us was actually on the Web3 side. So this really came heavily from my time at Cellos because I worked across so many different projects across the ecosystem. You start seeing the different challenges and complexities that they face across a number of different facets. So some of them are dealing actually with AML, anti-money laundering. How do I, as an application, respond to and deal with anti-money laundering within my application in a way that ensures still that I remain decentralized? And that was something that we saw, and it was a number of projects, and we saw that even across not just Cello, but other ecosystems as well. That's a pre-transaction logic. It also aligned really well with some of my background in policy, right? Where it's a common question that would come up amongst current and former regulators is, wait, how are we actually thinking about this as an industry? If you look at some of the remarks that the U.S. Treasury Department has had, they've talked about this very explicitly. They said, look, you've built all of this technology. You've used all this complex cryptography. You're talking about zero knowledge proofs, but you still need to fundamentally solve this problem. And it was very explicit if you look last year at the Blockchain Association, where the Deputy Secretary of Treasury, Wally Adeyemo, basically explicitly said this. So there was that aspect. But then it was, even at Cello, it was that there were other cases too, where it's like we need pre-transaction logic for different facets. So when we think of stablecoins, what are the requirements to mint a stablecoin? Is there sufficient collateral? Can you readjust the collateral if things change on chain or off chain? How do you do that? There's an exploit on an ecosystem, on a project. How do you, as another application, say, hey, look, we're not okay accepting your funds that have just been stolen because it doesn't, we're not okay with this fundamentally, because it's like, wait, like you just stole from our other friends, or you stole from us in another application. What's going on here? Or, even another one would be, you don't always need identity solutions. You don't always need to KYC. That's always kind of been the solution for any type of pre-transaction logic in crypto is, just have to put in KYC and you're good to go. But that's oftentimes not what's needed. There's just other fundamental facets you can use. And so it was the experience from there and saying, wait, as projects are getting larger, they need those kinds of things. And so it was very much coming from the Web3 side. And then as we dug in deeper, we said, oh yeah, wait, this is so logical. This makes sense that as they scale, they have to do this, because you can look back in Web2 and say, this is exactly what happened there too. And you had full dedicated teams to actually building those pieces out. Whereas in Web3, of course, you try to use the building blocks of other open source protocol that's built.
A question I have, so when someone develops essentially the requirements for the smart contract in order for it to execute, how do you prevent centralization within that process?
So the way our system works is essentially to issue signatures if a transaction meets a requirement. Now, the centralized way of doing this would be as a predicate team runs an operator and says, you know what, we will check every transaction for you. And if it looks good, if it meets the requirements, we'll confirm it. And the way you confirm it is you issue a signature on chain. Now, in crypto, it's probably not ideal if you're trusting me to tell you that your transaction meets your requirement, because now you're saying that, oh, Nikhil, you seem like a great guy, awesome, but I might be asleep, or maybe I decide that, it's not worth my time anymore, or I could say, look, I actually don't like the requirement that you have, I'm going to put it in my own. That's a huge trust vector and a centralization vector. So what we did instead was, what if we can build a distributed operator network? The distributed operator network is responsible for issuing signatures, but it's not any one individual. Right now it's a proof of authority model, but then it becomes a proof of stake system. And in that case, you have a network of operators that's responsible for checking every transaction for an application and say, hey, yeah, this meets the requirements, we'll issue a signature. The application team here, the developer or that ecosystem, can set the quorum for how many signatures they want. So again, they say, look, maybe they're okay with one signature, or maybe they're okay with a signature from a specific operator, or they can say, look, I want multiple signatures here. So you're able to kind of essentially have that decentralized model.
And another thing that we'd like to move towards is Eigenlayer. So I think first it would be great to understand how you're using and leveraging Eigenlayer, and then also why you chose to go with Eigenlayer, and if there are any other competitors you considered in that process.
The way we use Eigenlayer, why we use Eigenlayer is when we think about our operator network, as I just talked about. Now, we need a distributed network of operators. And we turn to Eigenlayer for that, in which you can have a distributed network of operators with economic security. That way, we can say when we go live, we can say, look, we already have a network of operators. If they behave maliciously, their economic security is slashed, all those things. That's really why we use Eigenlayer. And it's a really valuable solution because what it really lets you do is what you're trying to normally create in any type of network is you're trying to figure out what is the toughest side of your network. And so in our case, we have a network, and one of the key components of that network is our operators, right? You have applications that are integrating us, operators that are responsible for enforcing the policy is met and validating transactions. And then we have the other side of our system, which is actually kind of information providers, whether on-chain or off-chain, that supply relevant information to check whether a policy meets a requirement or not. Your operator or your validator network is always one of the most difficult sides of your network because you need to go and talk to a bunch of different groups that all run validators or operators, say, please run our system. It's really important that you do. We're trying to create a distributed network. That just takes up a ton of time. And I saw that personally as well. What Eigenlayer lets you do is say, wait, what if you just cancel out? What if you remove the toughest part of that network and say, you know what? Great, that's taken care of. Because if you do that, now we as a team can go and focus on the two other sides of our network, which is how do we make it feasible for applications to integrate us, and how do we partner with different information providers. Then your question of what other options did we look at? There's a few other ways we could do it. So one was we work with a proof of authority model similar to how Wormhole's Guardian network was set up. And in that case, that would involve, me and my co-founder going and talking to different validator groups and saying, hey, can you run kind of a signature issuance machine on our system, right? The other option was we would have looked at something like a Cosmos SDK, and we would have had to bootstrap a token because we would want to create a proof of stake system with a token on day one. That's a huge exercise because now suddenly what are we spending time on? Are we spending time on solving the use case of different partners who are working with, or are we spending time to launch a token? And really what would happen is you're spending time to launch a token. That's a huge resource drain. It slows down launch timeline. It really makes us focus on, again, this very difficult side of the network.
Well, I just want to talk about one thing. I don't know if you want to, but essentially just dig a deep because I saw one of your tweets that says that just partnering with Eigenlayer was one of the best things that happened because they provided so much support from GTM point of view and various other aspects. And if you can just sort of put some more light onto this, essentially the kind of support that the Eigenlayer team provides.
I think it fundamentally the support first starts with philosophical and values alignment, right? And I think one, you need to make sure you actually have that. And that was actually really important here. So even before we talk about any form of economic security, the question is what are we solving for? Is it valuable? Is it important? And they understood that part really quickly. And really the first conversation with Sriram I was like, hey, here's what we're doing. I actually just really want to get your thoughts on it. It had nothing to do with Eigenlayer. We actually hadn't thought about using Eigenlayer at the time. It was more, you have very good thoughts about the industry. You have really good thoughts about transaction flow, where the world is moving. And so it started with that. From there, then, of course, okay, so let's go through what was the type of support? So for us, it was then, okay, wait, we actually do need a model to build out our operator network. And so then we said, hey, isn't it possible to use Eigenlayer? And this was just purely off of the white paper. There was no documents yet. And so it's, hey, is there a way to actually do this? And Sriram was like, oh, wait, actually, he was like, oh, that's exactly how we're thinking about it. That's right. That is a big reason for why one would use Eigenlayer. So okay, great. From there was then being able to work closely with their engineering team and their developer team and figuring out, okay, what is the right model here? Thinking about our entire system, our entire flow. And this was before Eigenlayer was live, right? There was not that much documentation. And so being able to get their feedback, support on the actual technical design, that was really, really valuable. So it was basically being able to work with them as very close partners from very early on in our journey. And then, of course, as that's evolved, that continued support, right? Of saying, all right, here's what we're trying to solve for. But then after that, it's like, okay, great. I kind of think of it as they're helping us make sure we have everything in place and then saying, okay, great, go off and do what you need to do. Well, happy to work with you on any partnerships with other projects.
If today any, application just considering to sort of incorporate AVS model, why should they be doing it? How does it sort of essentially become part of the core as Web3 also sort of graduates?
there has to be a fundamental technical reason for why you want to do it. I think earlier in the cycle, there were a number of projects who said, oh, let's use this as a narrative, a way to bootstrap our narrative. But it wasn't so much that they really needed Eigenlayer. And I do think that all these things, these types of decisions, because you're incorporating a technical stack at the end of the day, it should be grounded in a technical view of, do we actually need this or not? And if you don't need it, then it doesn't make sense. Maybe you get, a quick bump of like Twitter followers or something like that, but it doesn't hold, right? Because you're not actually going to solve what you really need to solve for. And really, if you're building anything, your real focus should be, what am I solving for? It should be that day in, day out at all points in time. You should go to sleep trying to figure out what you're solving for. You should wake up being like, oh, what am I solving for? That should happen at all points in time. And so it starts with that first principle of, what am I trying to solve for? And then saying, okay, do I need this shared economic security? And I think once you start thinking about that, then you say, okay, great. Like, do we need something like Eigenlayer? Is that the right option? What is the assets I want to use as economic security? There's implications to your underlying token model if you already have a token, right? Or if you are planning to launch a token. There's very important things that one has to think about from that standpoint. And then the other part is, what was fascinating is the extent of how big Eigenlayer got, even though the AVSs were not quite ready for that scale. That was one thing I thought was fascinating, was earlier this year, in like January, February, everyone was talking about Eigenlayer. I remember going to ETH Denver in February, and that was one, every conference there's 2 or 3 big overarching narratives, and it was Eigenlayer was front and center for all of that. And I remember thinking, I was like, wait, none of the AVSs are ready for this yet. Like, we are not ready for this scale. We're still building. We're not going to be ready. We're not going to be live quite in time. And that's, I think, something that's happened is now you have a number of AVSs, and some of them are now starting to get a little bit bigger and actually start launching. And I think that's really the world that we're going into. So then you're going to have more sophistication as a result of that, with what you can do as an AVS, what you might not want to do. There's going to be a lot more learnings as well, because a lot of this was still highly experimental.
A lot of Web2 projects, which were sort of on the edge to jump into Web3, but couldn't for XYZ reasons. AVS has actually solved that, and thus in the next couple of years, that number can just shoot up. Like the applications on Web3, and the typical argument of crypto about where are the real world applications for Web3 and what are they solving. You think that'll be this can be one of the tipping points? This can really be a big thing for Web3.
Every infrastructure project hopes that they're in the position to be able to say, oh, we're activating that, right? And I also gave you the same explanation early on as well. I think about it as any of the infrastructure is designed to do that. And that is like ideally where we get to. And it's all these different pieces, right? It's AVSs, it's the world of dApp rollups and L2s. Intents make the same argument with solver networks. And you can see how like solver networks are not that different from things that are done in Web2 as well. All these different pieces are there. I think then it just comes down to, how are we actually using the technology? So far, the closest thing that we've had has really been stablecoins. And my view is actually stablecoins are what kind of is that first part to get us to much more general adoption. If you have stablecoins being used normally in your day-to-day, now suddenly that intersection with other applications on permissionless blockchains and even permissioned blockchains becomes much more seamless. But you have to have that first adoption to get you there. I don't think Eigenlayer gets you that first adoption. I think other things are what gets you into that first piece, but then things like Eigenlayer make it possible for that to scale. And so it's right now, I think it's like, you almost have this kind of funnel, or you can even think of that adoption curve. The adoption curve is right now we're at the part that we need to get to. We need to be able to get everyone to cross the chasm. And across the chasm, when you do, Eigenlayer is something that is set up for once people cross the chasm, it's there. But I don't think Eigenlayer in and of itself enables the crossing of the chasm. I think stablecoins are more likely to do that, whether that is, from a fintech standpoint. I think like Stripe is considering acquiring Bridge.xyz. Those are the kinds of things that I think pushes it. Eigenlayer becomes crucial once that happens, because otherwise, as an industry, we're entirely unprepared for anything, for any more meaningful level of adoption.
So as you mentioned, Eigenlayer has done incredibly well this year. Why do you think that was the case? Is it just a factor of the product, the right timing, the right marketing, or why do you think they've done so well if you could deconstruct it?
This was for a few reasons. One is they built something very novel and different. And I think when people understood the value of what they were building, say, wait, there's actual real fundamental value here. There's a need, there's demand. Then, of course, there is a marketing component of marketing a narrative of how do you express, look, like this aligns with the Ethereum ecosystem. This enables and empowers the overall Ethereum as a whole. You also had like a lot of around like token and the opportunity of saying, hey, wait, you have your risk-free your risk-free rate of return, which is ETH staking. And then on top of that, you're able to earn additional rewards from AVSs and all of those things. And so I think it was also this narrative part of, wow, this creates a new opportunity for what is built, as well as new opportunities for yield and economic systems. So it's both. I think of them as like the technical component and also the narrative. And then I think it was that reputation that they built, right? It was a very research-oriented team. You had Shriram is a professor, so you have that, a very articulate person. And so you build up that kind of cachet of like, look, this is a premier project that's building something that's just brand new that no one has thought about. It's novel technology. I think that's really how they became really successful. And I think the last part that they really used was a points program. They probably have one of the most successful points programs in the industry, right? Of everyone just going in to kind of track their points. So there's a bit of a degen aspect there as well, right? There's the academic component, there's a technical component, there's, hey, how are we building a better system overall? And then there was a degen component of points.
What's the biggest thing that you learned from the Eigenlayer team?
Yeah, I think the biggest thing I've learned from the team is really the power of narrative tied with strong technical. I've seen cases of like strong narrative, but not so much strong technical, or really strong technical with very minimal or not a narrative that doesn't land. But what I found from them was that merge of both and the ability to articulate that. That's unique. Not a lot of projects in the industry do it, but the ones that are able to kind of merge those two become really strong, at least from a scale standpoint.
And I guess this builds on that quite perfectly. What challenges do you currently foresee in scaling Predicate, and how are you thinking about overcoming them?
Yeah, a number of facets, right? So from a business standpoint, how do we continue getting more and more integrations for different use cases? Given that we're hitting all of transaction prerequisites, there's a lot of different things one can do. And so there's ways that our go-to-market style has been, have initial key integrations that you can then go wider with. The other way, of course, would have been that we go wide first and then try to narrow it down. But we went narrow first to then broaden, a bit of a Web2 style.
What are the narrow applications that you chose to go with?
So initial ones that we really honed in on from a use case standpoint were anti-money laundering, risk management, collateral requirements for collateral verification for RWAs, interop, and then intents. So those are where we went narrow. But as we talked about, it can go much broader in terms of any type of prerequisite. And so it's going to be continuing to chart that while also making sure that those initial ones are met. Like each of those is a bit different. And so, I think it's going to continue being basically saying, how do we meet the needs of initial partners? But then how do we ensure that we're building something that's scalable and can continue broadening out and then becomes, a permissionless network. It can't be reliant on us as a team to continue maintaining it. And the other part is from a technical standpoint, right? Like how do you build a robust, scalable protocol that has sub-second latency with a distributed network of operators? Like because we are something that's used before a transaction happens, it's really important that everything works well. If there's delays, like it's a problem, right? And it can't be something that takes 5 seconds. Like this has to be sub-second, like 0.5 seconds or even less, right? And so we have to be able to do that. From a technical standpoint, that's not easy. And so those are the other parts that we have to really think about.
If you don't mind diving into how big do you think this, essentially overall ecosystem can be? Liquid restaking and using that security for AVSs. As you mentioned, joining the dots with the fact that AVSs, especially like Predicate, have this massive requirement and they have to be exponentially fast because they are coming right before the transaction goes the network, right? So they need to process this absolutely at an insane speed, honestly.
So my view is that it will, when I think of restaking and Eigenlayer or, any other, I think of the total market of restaking. So, we can say whether it's Eigenlayer or any of the other restaking platforms as well. it is such an effective way to launch an application when you think about any type of decentralized system. And so my view is that if it starts becoming a bit like, a Google Cloud or an Azure or an AWS, right? Which is a lot of applications in Web2 use those platforms to initially launch. It makes a lot of sense. I think I see it somewhat in a similar fashion, where if your tooling is done right, in the same way that there's a lot of good lessons, I think, with L1s and L2s of, like now you have a lot of dApp rollups, right? And you have rollups as a service. And in the same way, it's like, as you start having these more complex applications built, the same way you're like, hey, like, how can I more quickly launch that? So I think that is a world that we go into, is that you're going to have a lot of those. The big question, I think, then that leads to it is, does everyone stay using a restaking system, or do they eventually migrate out? Do they graduate, right? That part, I don't know. I don't know if it means that, there's a constant flow of new groups, or is it that you use some components still of your protocol as an AVS and some you don't, you start migrating out over time. Kind of similar to if you're building an L2 rollup, there might be a world in which you first start with using a RAS, a rollup as a service, but then say, okay, wait, we've hit a certain scale and we have to start doing more customization. It doesn't make sense for us to use a rollup as a service. We need to do something else, but we are sufficiently large to do that, right? That's how I think about it. Now in the world of, okay, cool, like, is it Eigenlayer, Symbiotic, Babylon, like any of those? Then it starts getting trickier. I think it then comes down to which is the best platform for what I need. What are the assets that are there? How is the technology built? What are the differences? What are the operator network? The other part is too, like, if you have AVSs all in the same restaking platform, you're able to do more interesting integration. So what is the ecosystem on Eigenlayer? And so if that's the case, which AVSs will we work with? Because we can create a more integrated stack that's built all through the same restaking, on the underlying restaking platform.
So with that point, I'd love to understand how you think about startup strategy, particularly when you have limited resources. So earlier you mentioned like not choosing to use the Cosmos SDK, then there's no TGE, which requires a lot of focus, which is a bit of a distraction from the product itself. So how do you think about making strategic decisions with those limited resources available?
It's a constant cycle of chaos. And what you're trying to do is you're operating with a hypothesis of what are the things I need to prioritize and make the best decision you can at that point in time. And so it's starting research first principles, saying, what are we solving for? And if you're optimizing for what you're solving for, that can at least get you to the best outcome of saying, great, like, then what do we prioritize? Because there's an infinite number of things you could prioritize. And so in this case, for how I've tried to think about it is, what are we really trying to solve for? And how do you get to that? How do you get to that outcome? It all starts with first principles from a research-oriented approach. Everything is a hypothesis to get you to what is the end outcome you're trying to get to, and what are the intermediate outcomes you need to have to get to that final outcome.
What's the most controversial opinion that you heard about Web3 and shared with anyone before?
I think by us calling in the Web3 industry, calling it cryptocurrency, I think was actually wrong. I think it should have been crypto commodity. And the reason why is I think over time what happens is, you have, right now a big question is how do we get retail people to buy our token as utility, all those things. But I think the world we get to is, the world is too complex for us to be able to make decisions on what is the right asset to buy over time. And what we're doing through the concept of cryptocurrencies, we're actually only making that more and more complex. You have rational decision makers who have complete information to be able to make a decision, right? That's how we always thought about how societies operate, how people operate. But I'm not convinced that we're actually able to do that. And I think we see this in the price of tokens. We see this for how projects operate, all those things. I don't think rationality is what actually holds here. And so what we have to think about here is, how are we abstracting away complexity when we think about the underlying system? So I think articulating it as cryptocurrency suggests that we should all be holding every different asset. I don't know if that's really how the world works, because I think that makes things way too difficult.
Awesome. Now for my favorite part of the podcast, which is a quick fire round. So essentially we're going to ask you 5 questions. The goal is for you to answer with the first thing that pops into your head and to just make it very quick and rapid. Hence the name. You ready?
Yeah, sure.
What's the biggest misconception about liquid restaking?
That it is that's not real, that it's basically like you're just rehypothecating and it doesn't exist.
Who is your biggest inspiration and why?
My biggest inspiration is, this is from a professional standpoint, not personal. No one in crypto. It's actually Brian Stevenson at the Equal Justice Initiative, which is a criminal justice reform nonprofit. Had a chance to work there, so yeah.
And why is he your biggest inspiration?
It was very much this like commitment to public service and building an organization in a part of the country that was not at all easy to build. So if you've read Just Mercy or watched the movie, it talks a lot about this. In this case, it was from basically what the Equal Justice Initiative does is it represented people on death row, incarcerated individuals who did not receive fair trial. And this is like a very tricky topic to navigate, especially in the United States when we think about the criminal justice system and its history, especially in the Deep South and places like Alabama, where actually, as much as the United States would talk about a fair and impartial trial, with the right to legal counsel, many people actually didn't get legal counsel. And so operating in those types of environments is not easy, and building an organization is not easy in those places, and building it from scratch. So yeah, I think that's really why.
I like the answer. Next question. What's the biggest mistakes you see new projects make?
Lack of focus.
Is fundraising a game of FOMO?
Oh, absolutely. It definitely is a game of FOMO. As much as you like to think it's not, it very much is a game of FOMO.
Last question. What is the biggest overhyped narrative right now?
The one that I think is the most overhyped right now is the intersection of AI and crypto. That I think is the most overhyped one from a funding standpoint in terms of like what's happening. I think that's the one that I think is the most overhyped at the moment.
Why do you think it's overhyped?
Because I'm not sure yet if we're really operating from a standpoint of what are we solving for a lot of these. I think there's going to be a few projects that are very much doing that. And that's absolutely the case, right? I'm not going to dismiss, like, there are projects that I think are very much like, okay, cool, what are we solving for? For example, Vana, I think is saying, look, like when we really think about data ownership, there's something fundamentally valuable there. I think that's great. But there's a number of other things where it's like, okay, wait, so what are we really solving for here? Is there really a need for another group that's issuing a token to be able to collect data for users to be able to submit data that then goes to some LLM types of things? And so you can only have so many of those. And yeah, I'm not sure. I think that's very much like you put in, I think it's happening a little less now, but there was this period of time of like, put AI in your system and then there you go, right? And technically, we could have as well, right? We actually didn't fundraise around any aspect of AI. We didn't even mention it. But there are very clear AI use cases that we can power. But are we there today? No. So then, like, why are we fundraising around that? But I think there is very much still this aspect. The other part that's fascinating is I'm not sure yet if the world of AI actually respects crypto when crypto talks about AI. And that's noticeable, right? There's still a gap between the AI crypto and AI from an AI standpoint. And I think that has to be bridged if this is less of a hype and more of something real.
Awesome. Well, thank you so much, Nikhil. What is the best way for people to support you and Predicate as well?
Yeah, so they can follow us on Twitter, check us out on Twitter, reach out from our website or reach out through Twitter. I'm also on Twitter, so they of course can get in touch with me there. I'm super active, so if anyone shoots me a message, I'm generally pretty responsive.
Awesome. Thank you so much, Nikhil, for joining Depesh and I.
Thank you. Thanks for having me. This was awesome.